This section is 3.4. This is solving multi-step inequalities. So we've already worked through solving inequalities, but these ones have multiple steps to them, okay? So let's look at our different possibilities. So first off, you can have a one solution where you solve it just like a normal equation, right? But we have to remember that as we're solving it, we need to flip the sign when multiplying or dividing by a negative number. So flipping the sign being if it's less than, then we change it to greater than, right? Flips going the other way. So let's do an example. So here's an example of a multi-step inequality. So we can see that it's going to take 2 steps to solve it. That's why it's called multi-step. So we treat it just like an equation. So we go back to our knowledge from chapter 1. And we say that we need to go in backwards order of PEMDAS. So the first step here is actually going to be subtraction. So we subtract 7 from both sides. Okay, I don't need to flip the sign because I didn't multiply or divide at all. And then on this next step, we need to multiply by -6 to get rid of the -6 on the bottom here. And so now we see, okay, I did just multiply both sides by a negative number. So now the sign needs to flip, so now it's going the opposite direction. We had less than, and now we have greater than. And our answer is y is greater than -12. So that's just like a one solution. Technically, there are infinite solutions to what y could be, but this gives us just one option or one path that it can go down, basically. That's what that kind of means. And then we just graph it, just like that. And that should be fairly easy if you already know how to do 3.3. If you've already been solving inequalities, adding in the extra steps shouldn't be a problem for you, right? So let's go ahead and do page 128, numbers 1 through 3 all. So go ahead and pause the video and then come back. Okay, let's go ahead and work through them. So working through number 1, we gotta add 1 to both sides to start. And that gives me 4b is less than 7. Divide by 4. Divide by 4. And I get b is less than 7/4. And there's nothing wrong with leaving your fraction just like that, okay? For the sake of graphing, I'm just going to only include 3 numbers each time. So my middle number that I'm including is the number I care about, which is 7/4. The numbers beside it are going to change by going either down or up in fourths. So if I'm going to the left, I'm going to go down. And that's going to give me 6/4. But instead of writing 6/4, I'm going to simplify that down to 3 halves. Okay? And then if I go this way, it's now 8/4. 8/4 simplifies to 2. Okay? And then I'm going to put a circle, open circle above, because this has no line underneath it. And then the b is touching the small side, so my numbers are getting smaller, so I need to go towards the smaller numbers, which means towards the left side. Okay? All right, let's do number 2. And this one I'm going to go through a little bit faster, because we've already kind of been doing this for a few sections now, so we're going to kind of move a little bit quicker. So this becomes -36, divide by 9, divide by 9, c is greater than -4. So notice I didn't divide or multiply by a negative number, even though that there's a negative number on this side. Look at the number that I'm dividing both sides by. It's a positive number, +9. Okay? For this one, I'm going to have -4 in the center. If I go one step to the left, it's -5. One step to the right, it's -3. Close circle to the right. Okay, or close dot to the right. Okay, let's do the next one. Number 3. -11 from both sides. I get n over -2 is greater than 1. I'm going to multiply both sides by -2. Okay, notice I'm multiplying here by a negative number on both sides, so that means I need to flip the sign. So here's where I flip the sign. N is less than negative 2, okay? Now when I go to write the graph of this, I need to include negative 2. If I go one step to the left, it's negative 3. If I go one step to the right, it's negative 1. Closed circle, or not closed, open circle to the left. Okay. So now let's talk about what happens when you have no solution. So you get a situation where you have no solution if the inequality turns out to make a false statement. So when you simplify it, if it creates a false statement, then you know it's got no solutions to it, okay? Let me show you what I mean. So let's say you start out with this example. This looks a lot more complicated than what we've been doing before. But once again, you just solve it like a normal equation, like you would a normal equation, and then see what you get. So my first step here is to distribute. So I distribute the 4 to each side, and that should give me 8x plus 12. Okay, this side stays the same. Now from here, remember that before I can start actually solving for x, I need to get x all on one side. So if I'm going to get x on both sides, I need to subtract this 8x from this side. But then when I go to subtract the 8x from this side, watch what happens. Notice that it actually cancels out both of them. And since it cancels out both of them, we get negative 3 by itself and 12 by itself. And then when I examine the statement that's left over, so notice this only happens when the x disappears. So the x disappears, all of our mystery is now gone. And now we're just left with a statement that says negative 3 is greater than 12. Well, is that a true statement? No, it's not. Negative 3 is not greater than 12, which means there's nothing I can plug into x in my original inequality, nothing I can plug in for x that will ever give me a true statement out of this. If that's true, then I have no solution, okay? There's nothing I can plug in. And then my graph, I just included 3 numbers on it just to show that you do need to have some kind of graph, but I'm going to leave the graph empty because there's no solutions. Remember, everything we're drawing on the graph, if we look back at these three problems, everything that the line is covering are possible answers for what the variable could be. That means that if I plug in any number smaller or on this side for b, I should get a true statement. But there's nothing I can plug in for x to give me a true statement here. That's why we have no solution, okay? So let's look at infinite solutions. Infinite solutions happen if the inequality is always true, that you could plug in literally anything for x and you get a true statement. For example, if we start out with something that looks like this. Let me move this up a bit. Okay. You're going to distribute the 2. If I distribute the 2, I get 10x minus 2 is less than or equal to 7 plus 10x. Once again, just like I did before, I need to get the x's on the same side. So I'm going to subtract 10x from both sides. And notice it's the same type of problem. I'm getting rid of the x on, on both sides on that. Now, I didn't intend to do that, but that's just what happens when you go to move one of the x's, okay? Both of them go away. And now I'm left with a statement that just says negative 2 is less than or equal to 7. And notice this is the opposite of what we got last time. This statement is always true. This is just a true statement, which means I can plug in anything for x and get an answer, which means when I go to make the graph, instead of having an empty graph, I actually end up having a line that goes in both directions. No dot, no open circle, nothing like that, just covering every single possible number, right? Okay, so let's go ahead and do page 129, numbers 4 and 5. So you go ahead and pause this and then come back and we'll work on it together. Okay, welcome back. We're going to go ahead and work on this, and I'll zoom in on this part so we can see what's going on. Okay, so I'm going to go ahead and solve number 4. First step is I'm going to distribute this 2. When I go to distribute the 2, I end up with 2 times k minus 10 is less than 2k plus 5. Okay, now we have a situation where I need to move a k to the other side. So I'm going to choose to move this one, minus 2k which means I got to do it to this side. But notice both of them go away. And now I'm left with negative 10 is less than 5. Well, is that true or false? Well, since it's true, negative 10 is always going to be less than 5. I can plug in anything for k, which means my answer here is infinite solutions. Okay? And if I were to draw a graph for this, I might just include 3 numbers, 0, negative 1, 1. Doesn't really matter what numbers you include, as long as if you show some kind of line going in both directions forever, right? Covering all the possible numbers. Okay, next problem. Distribute the negative 4. This gives me negative 12n plus 4 is greater than negative 12n plus 5.2. Okay, for this one I need to get rid of the n on one of the sides, so here I have a negative 12, so I'm going to add 12, and then that means I need to add 12 to this side. When I do that, once again, both of these things get canceled. That's not always going to happen, but it just happens to work out this way. And now I get a statement that says that 4 is greater than 5.2, but that's not a true statement. So the answer here is no solution. Okay? And then when I go to draw the graph, this time I have my numbers 0, negative 1, 1. But as soon as I'm done drawing the graph, I'm done. Got to leave it empty. And that is section 3.4.